Here's a weather radar composite across the United States. We use weather radar to monitor storm developments where precipitation is occurring, possibly hail or even tornadoes. The Doppler will detect the movement inside of the storms, change in frequency as the signal comes back to the radar. So we use Doppler radar especially for detecting rotation in thunderstorms and seeing when a tornado might form. It's extremely helpful in the warning portion of the National Weather Service's services. Here's a closer up look of a composite of radar overlaid on top of satellite, which is used in the National Weather Service quite often to try and see, where the low pressure is and frontal boundaries, and just seeing where the storms are forming in relation to the moisture that's feeding them. So it's kind of a neat way to utilize a combination of different weather details to predict the immediate future of what's going on with thunderstorm systems. Sky watching. There's going to be a real-time weather portal link that you're going to utilize, and hopefully quite frequently, because as you go through this course, you're really going to want to apply the things you're learning to real-time weather that's occurring right now. And that real-time weather portal will give you a way to analyze the weather from home on your own computer in a way that the Weather Service people or even any meteorologist would, just looking at high and low pressure systems and weather maps. So sky watching is a good start, in this course, to just getting yourself familiar with weather. And obviously the first thing you'll see outside are clouds. Clouds are, water droplets. The moisture condenses on cloud condensation nuclei, little pieces of dust in the atmosphere. The moisture will condense on something, and that's usually dust. And the lower the cloud, usually the better chance you're going to get precipitation, and the better chance that the cloud itself is still water. The higher up in the atmosphere, the thin cirrus clouds are all ice crystals. They're fibrous. They're being blown around by the jet stream. Usually not a lot of precipitation comes from the higher clouds, but we'll cover all the different types of clouds as well. Fog is actually cloud in contact with the ground. You're dealing with moisture at the lowest levels that have condensed into the air, and fog happens usually later at night and in the early mornings, especially in summertime when there's a lot of moisture at the ground level. So that's one type of cloud, so to speak. There's other cloud forms. Stratiform clouds are usually a continuous sheet of very similar cloud looking smooth, horizontal layers. They form when the air is gradually ascending or descending, or gradually ascending over a very broad area. So as the air lifts slowly and over a uniform area, you'll create stratiform clouds. There's another type called cumuliform, which are more puffy. They're rising in individual columns, much smaller scales. So you'll get fair weather cumulus, what we call it. No rain falling, but more organized updrafts can actually generate into thunderstorms. So cumulonimbus is what we call a thunderstorm cloud, cumulonimbus, where you're actually generating lightning and precipitation. The high wispy clouds in the western sky is usually the first sign of an approaching warm front most of the time, but any kind of frontal boundary will start off with usually high, thin clouds approaching and filling and thickening up. And then clouds of vertical development are emerging and vertically growing cumulus clouds, which will eventually evolve into what the picture you see here is a cumulonimbus. Nimbo or nimbus prefix or suffix equals rain producing. So cumulo is a cumulus cloud and nimbus meaning rain. There's also lightning and hail and very strong winds that can occur in cumulonimbus cloud systems. When you're watching the sky, you'll definitely see cloud movements in different directions at different heights in the atmosphere, or different altitudes. The horizontal wind shifts with altitude most of the time. So at the ground, you may have a south wind creating cumulus clouds, and cumulus clouds will be blowing from south to north. further up in the atmosphere, the winds will be out of the west, so the mid and high clouds will be moving from west to east, and you'll see that distinct change in direction of motion if you just watch the sky for even a short period of time. All right, in conclusion for this particular chapter, just remember you're getting the base groundwork for what does a weather map look like, how do we get weather information. You know, we record observations, we use satellite images, and we use radar to get the big picture of what's occurring in the atmosphere and how is it going to evolve over time and develop and move across the United States. So, you know, everything you learn in this chapter is going to be utilized throughout the rest of the course. You know, and as I mentioned, you know, do a sky watch as often as you can just to see what's going on. Go to the real-time weather portal and see what weather may be approaching you and see what the sky looks like as that's occurring. So even some of you might even have weather monitoring instruments at home, temperature gauges, or even a rain gauge. So you know, you follow along as well and utilize those to just reinforce the information you're learning in the course. Thanks, and I hope you enjoyed the lecture.